Hello everyone, I'm Jacob Jasinski, and today along with my fellow classmates Ethan Saylor and Nicholas Shoup, we're going to be discussing acid rain and the effects it has on the environment. Now, what is acid rain? Acid rain refers to a mixture of deposited material, both wet and dry, coming from the atmosphere, containing more than normal amounts of nitric and sulfuric acid. Now, simply put, it means rain is acidic in nature due to the presence of certain pollutants in the air due to cars and industrial processes. It is easily defined as rain, fog, sleet, snow that has been made acidic by pollutants in the air as a big result of fossil fuels and industrial combustions that mostly emit nitrogen oxides and sulfur dioxide. Acidity is determined by the basis of the pH level of the water droplets. Now normally, rainwater is slightly acidic with a pH range of 5.3 to 6.0 because carbon dioxide and water are present in the air. They react together to form carbonic acid, which is slightly acidic, but it's very weak and non-harmful to us. And when the pH level of rainwater falls below this range, it becomes what we know as acid rain. Now, acid rain isn't entirely the fault of man-made things. Although man-made creations do contribute a large amount to the true emissions that breed acid rain, there are also natural sources. Nitrogen oxide can be formed by extreme heating of the air during a lightning storm. Sulfuric acid is discharged from volcanoes during eruptions and from rotting vegetations. The real problem, though, as the emissions created by man-made machines, large contributors of nitrogen and sulfur oxides include the burning of coal and other fossil fuels. For example, in 2007, electric power generations accounted for 69% of total sulfur dioxide and 20% of nitrogen oxide emissions in the US. As long as emissions are being released into the air, no matter the source, the chance of acid rain is there. Now, my classmate Nick Shoup is going to be discussing some of the effects of acid rain.
Okay, so acid decomposition can damage leaves and deplete nutrients in forest soils and trees, which leads to trees being left vulnerable to disease and environmental stress. When lakes and streams become more acidic than normal, they can no longer support the same types of fish and aquatic life as before. For example, a healthy lake contains a pH of around 6.5 or higher. Only a few species of fish can survive at a pH of below 5. And once a lake or water mass reaches a pH level of 4, it is considered dead and can no longer support life. So, crops can also be affected by acid rain. They can potentially reduce agricultural production by changing the chemical properties of the soil. Now, what do I mean by changing chemical properties of the soil? Well, slowing the rate of microbiological processes and reducing the soil nutrients. The roots of natural vegetation and crops can become damaged due to stunted growth.
Now, we've been talking a lot today about how clean, fresh water is important to life on our planet. And so I thought we could set up a little experiment here to really test that out. Now, acid rain is one form of pollution that can affect our water supply. And so I set up this experiment, and I took these two ferns, and I set this up so that for 5 days, I watered and misted this one with regular water out of the tap. And this one I watered and misted with a vinegar solution, which is acidic, to simulate the effects of acid rain. And you can see that it really this poor plant had a bad effect on it and has really demonstrated what can happen if acid rain falls on our plants. And not only does it affect plants, but it affects all sorts of other living organisms, things that live in our streams and lakes. It can cause fish to die or not to be able to reproduce, and then that can have effects all the way up the food chain.
Up next, Ethan Saylor will talk to you about the effects of acid rain with this wheat crop growth and also the solutions to acid rain.
Now, we mentioned before that it is detrimental to crops to be poured on by acid rain. This is wheat crops, and as you can see, as the pH levels grow, the growth actually increases. That's because a pH that is lower is actually more acidic. So, as you can see by the graph, the bars with the lower pH level are lower, which means with more acid in the soil, the wheat crops suffer from growth. Now, while it is important to know that acid rain does in fact affect the organic growth, it can also affect man-made growth. Because it is acidic by nature, things such as metal or even like sculptures made out of rock can also be deteriorated from being rained on by acid. So, how do we fix acid rain? Well, the solution is quite simple, considering that it is due to excessive emissions due from combustion of coal or other fossil fuels. The solution would simply be to convert over to renewable sources of energy, sources that are much cleaner, such as wind energy or hydroelectric power, or similar things like that. So since these don't involve combusting anything, they don't release emissions into the atmosphere, thus reducing the risk for acid rain. Another thing you can do is slightly more personal, and that has to do with your car. Since cars also burn fossil fuels, driving them around is contributing to the acid rain problem. So just simply driving it less, that can help. Even better would be not driving it at all, or maybe buy a car that's electric or a hybrid. Another thing you could do is switch your house over to renewable energy, such as installing solar panels. That would also work too. All of this contributes to reducing the emissions output and thus reducing the acid rain. And yeah, that's pretty much it. Over the presentation, we covered basically what acid rain is, what it can do to organic stuff as well as man-made stuff, and also a few solutions to making acid rain less of a problem.